Today we are going to learn atomic structure. Atomic structure deals with the structure of an atom and its properties. First of all, we are going to review some important points in that lesson. Then we will see some 3 marks and then 5 marks questions in detail. And at the end, I am going to list some important questions. Yeah, let us start with important points. An electron is said to have a dual character. Why? Because an electron has particle character as well as wave character. So, it is said to be dual in nature. Next, by applying Schrödinger wave equation to hydrogen atom, the energy of an electron in any orbit can be calculated using the formula En is equal to minus 2 pi squared m e power 4 divided by n squared h squared. We know pi is a constant, mass of particle is constant, E exponent, h is Planck's constant. So, the variable value would be n. N refers to principal quantum number, nothing but orbit number. Next, let us define what is an orbital. An orbital is the region of space around the nucleus where the probability of finding the electrons are maximum. Next, now we are going to see what is a node. Just now we learnt what is an orbit. So, the difference between an orbit and a node would be, as I defined earlier, an orbit is nothing but an area around the nucleus where the probability of finding the electrons are maximum. But a node is an area around the nucleus where the probability of finding the electron is 0, that is no electron. Actually speaking, immediately after the nucleus, we do not have any nodal plane. Nodal plane refers to no electron. But only after the first orbit, we have the first nodal plane. So, between the first orbit and second orbit, we have one nodal plane, and between second orbit and its higher orbit, we have another nodal plane, and so on. So, the number of nodal surfaces or nodes in s orbital of any energy level can be calculated using the formula n minus 1. Why do we subtract number 1 from n? Because between the nucleus and the first orbit, we do not have any node. That is what the orbit number is subtracted by 1 in order to get number of nodes, where n is the principal quantum number. Next, as you apply molecular orbital theory to predict whether a molecule is formed or not, we will be minding 2 important things. One is number of electrons in bonding molecular orbital and number of electrons in anti-bonding molecular orbital. We know bonding molecular orbital lies in the lower energy level, anti-bonding molecular orbital lies in the excited state or higher energy level. So, if the number of electrons in bonding molecular orbital is greater than number of electrons in anti-bonding molecular orbital, means the bond order is positive, that is greater than 0, a molecule can be formed. As the bond order increases from 1 to 2 and 2 and 3, the strength of the bond also increases, the stability of the molecule also increases. For example, the bond order of oxygen is O2, that is between 2 oxygen atoms, a double bond is formed. The bond order of nitrogen molecule would be 3, that is between 2 nitrogen atoms, a triple bond is formed. Next, as you apply the molecular orbital theory to predict whether a molecule is formed or not, we have to use 3 important principles. One is Aufbau principle, another one is Pauli exclusion principle, and another one is Hund's rule of multiplicity. You have learnt last year about all these 3 principles. That is, according to Aufbau principle, the electrons are arranged from lower energy level to higher energy level, that is from first orbit to nth orbit. According to Pauli exclusion principle, no 2 electrons can have all the 4 quantum numbers identical. According to Hund's rule of maximum multiplicity, the sub energy levels of any energy level should get 1 electron each before pairing. Yes. Next we move on to electronegativity. What is electronegativity? Electronegativity is defined as the tendency of an atom in a molecule to attract the shared pair of electrons towards itself. Yes, in general, if you see the periodic table, you will find on the left side metals, and you will find on the right side all the non-metals. What is meant by metal and non-metal? Metals are metallic. That means they have the tendency of giving out electron and acquire positive charge and to attain the stability. Non-metallic characters nothing but they are the elements having the tendency of gaining one or more electrons and acquire negative charge and also attain the stable form. So, in general, the elements occurs in the right extreme of the periodic table except the 18th group, noble gases. That is, I am talking about the 17th group and 16th group and so on. Those elements are highly electronegative. So, we have the following electronegativity order. We know the fluorine is the first member of the 17th group elements. Fluorine is the highest electronegative element, then oxygen and then nitrogen. So, this is the very important point regarding electronegativity. So, fluorine being highly electronegative, which readily forms hydrogen bonds. So, not only fluorine, all these three, since they are highly electronegative in nature, they are capable of forming hydrogen bonds. So, there are two kinds of hydrogen bondings: intermolecular hydrogen bondings, that is formed between two molecules; intramolecular hydrogen bonding, that is formed only within a molecule. Just imagine we have the intermolecular hydrogen bondings formed by all these three elements, that is between hydrofluoric acid and between water molecules and between ammonia. So, the bond formed between fluorine and hydrogen would be very strong than the bond formed between oxygen and hydrogen, which is stronger than the bond formed between nitrogen and hydrogen. The reason behind is the electronegativity order is such. And once again I remind you that fluorine is the highest electronegative element. So, the bond formed by fluorine also is very strong. So, that we have the order, strength of hydrogen bonds. So, as I said earlier, there are two kinds of hydrogen bonding. One is intermolecular, that is formed between molecules, and intramolecular. Now, let us see what is intramolecular hydrogen bonding. So, intramolecular hydrogen bonding is formed within a molecule. For example, orthonitrophenol, we have intramolecular hydrogen bonding, that is between OH group and NO2 group. And in salicyl aldehyde, we have intramolecular hydrogen bonding, that is between OH group and CO group of CHO. And in salicylic acid also, we have intramolecular hydrogen bonding, that is formed between OH and COOH group. So, what is the application of intramolecular hydrogen bonding, or otherwise you can say what is the difference between intermolecular and intramolecular hydrogen bondings? Intermolecular hydrogen bonding, since it is formed between molecules, that increases the boiling point and also which increases the solubility in water. But intramolecular hydrogen bonding, since it is formed within a molecule, which decreases the boiling point and also which decreases the solubility of the molecule.